All right. Uh, Implicit differentiation, which means you just go after it and use a bunch of chain rules. Um, I'm going to work the right-hand side first because it's a heck of a lot easier to work. So we'll get 9x squared, and that's it, right? All right. So now I'm going to bring the sine of 2x cubed y cubed over here, and so I can just put the work in here. Now, the derivative of the sine is the cosine. So I know this is going to be the cosine of 2x cubed y cubed, but then times some type of chain rule. Yeah. All right. So now I have to do a chain rule on 2x squared y cubed. Because if it was sine x, it'd just be cosine x. But since it isn't, I have to do a chain rule on this guy. This guy's a product, so I need the product rule. So I'm going to take my u, my first thing, as 2x squared. My du is going to be 4x. My v is y cubed. My dv, or v prime, however you want to think about it, is 3y squared times y prime. Because since everything is being done with respect to x, whenever you have a y, you have to do y prime. Alright, so it doesn't really matter. It's going to be multiplying across. So I'm going to take 2x squared times 3y squared y prime plus 4x y cubed. And now I'm looking at this and saying, this is terrible, right? And this stuff ends up being in here, but I'm not going to put it in there because I don't want to waste my ink. But since it's cosine times something plus something, I could distribute, right? So it'd be the cosine of 2x squared y cubed times, that'd be 6 x squared y prime plus the cosine of 2x squared y cubed times 4xy cubed. This is one of those problems I think that they just put on there to make your life miserable. It's okay though. And so that's the entire right-hand side, or the left-hand side. So I'm actually going to take that and say that's equal to 9x squared. Do you buy what I did? Because I needed to do this, and it just so happens this ended up being all of that stuff right there. So, now granted it doesn't look all that neat and nice and pretty, but it gets the job done, right? So instead of rewriting everything, I'll bring that 9x squared over with me. Now, the key is, what are we solving for? You're solving for y prime. Yeah, so we're solving for y prime. So I need to get everything as far away from y prime as possible. So I'm going to subtract this guy, this cosine times the 4xy cubed, from here. So I'm going to get the cosine of 2x squared y cubed And I'm going to put this out front because I don't like stuffing behind the cosine when I don't need it. 6x squared y squared y prime. And that's still my focus. So I don't have a highlighter that works on this paper, so I'll just circle it with a weird color. And I'm going to subtract that, so I'm going to get 9x squared minus the cosine of 2x squared y cubed times 4xy cubed. And if I was thinking straight, I would have put that in front of the cosine. Just because, like I said, I don't like to have stuff behind the cosine, because then we start thinking it should go with the angle, and it shouldn't go with the angle. But now I'm going to divide everything by the 6x squared y squared, and then the cosine of 2x squared y cubed, and I'm going to divide that by 6x squared y squared cosine of 2x squared y cubed. That's one term. And now I'll get another equally weird looking color. That stuff divides out, that stuff divides out, and I'm left with what I wanted to have in the first place, y prime. And now I'm going to make this all neat-ish. 9x squared minus 4x y cubed times the cosine of 2x squared y cubed all over 6x squared y squared times the cosine of 2x squared y cubed. And I really don't think that I want to do anything else with it. Does it make sense how we got there? The biggest liberty I took is just taking that equation that would have been after I implicitly derived both sides, and I just rewrote it down here after I figured out that left-hand side would have been huge, and I didn't leave a lot of space on the paper.